Okay, today we're going to talk about trig identities and equations. I want you to be very careful when you're working through this section and pay attention to what you're doing. These are not difficult, but they are very different from what you've seen. We're going to be using the fundamental trig identities to verify identities. The fundamental identities are here. You may want to stop, take a picture of this, write it down. Reciprocal identities, quotient identities, Pythagorean identities, and even an odd identities. To verify an identity, we show that one side of the identity can be simplified so that it is identical to the other side. Each side of the equation is manipulated independently of the other side. Start with the side containing the most complicated expression. If you substitute one or more of the fundamental identities on the more complicated side, you'll often be able to rewrite it in a form identical to the other. So we're going to start with the first one here. It says verify that the cosecant times the tangent is equal to the secant. So we're going to start by working on the side here, and we're going to rewrite cosecant as 1 over the sine of x times the tangent. We're going to write that one as sine x over cosine x. Now, we're going to be multiplying these together. I'm going to simplify here. So I'm left with 1 over cosine x, and 1 over cosine x is secant x. So I have verified my first identity. The next example says to verify that sine minus sine x cosine squared x is equal to sine cubed x. So we're going to start with the right hand side, and I am going to factor on the left hand side. I'm going to start with the left hand side, and I'm going to factor out a common factor, which is sine x. When I factor out sine x, I'm left with 1 minus cosine squared x. Well, I know that 1 minus cosine squared x is really sine squared x. So when I multiply sine squared x by sine x, I get sine cubed x. So I have verified this identity. The next identity says to verify that sine x over 1 plus cosine x plus 1 plus cosine x over sine x is equal to 2 cosecant x. We're going to start here by getting a common denominator. I'm going to need to multiply the first one by the common denominator. Well, first I need to determine the common denominator. It's sine x times 1 plus cosine x. In order to change this fraction into this fraction, I had to multiply by sine x in the top and the bottom. So that's going to give me sine squared x. I'm going to change this fraction so that it has the same denominator. In order to do that, I had to multiply by 1 plus cosine x on the top and 1 plus cosine x on the bottom. So I get 1 plus cosine x all squared here. So, rewriting this, I have sine squared x over sine x times 1 plus cosine x plus 1 plus cosine x all squared over sine x times 1 plus cosine x. So I need to do this. I need to do it by FOIL. I'm going to do it over to the side. 1 plus cosine x times 1 plus cosine x. When I FOIL that out, I'm going to get 1 plus 2 cosine x plus cosine squared x. So I have sine squared x over sine x times 1 plus cosine x plus 1 plus 2 cosine x plus cosine squared x over sine x times 1 plus cosine x. I'm going to combine that all into one fraction. So my denominator is sine x times 1 plus cosine x. My numerator, when I combine those numerators, I'm going to write sine squared x plus cosine squared x plus 1 plus 2 cosine x. Now we know that sine squared x plus cosine squared x is really equal to 1. So this is 1 plus 2 cosine x over sine x times 1 plus cosine x. So I have 2 plus 2 cosine x over sine x times 1 plus cosine x. Now I can factor out a 2 from the top, so this is 2 times 1 plus 1, or 1 plus cosine x, over sine x times 1 plus cosine x. Now that I factored those out, they will cancel. So I have 2 over sine x, which is equivalent to 2 times 1 over sine x, which is really 2 cosecant x, which is exactly what I'm supposed to get right there. That one was kind of long. You have to practice these before you know exactly what you're doing. But if you don't practice, you certainly will never know. So you just keep trying and keep trying. Number 4 says to verify the identity 1 over 1 plus sine theta plus 1 over 1 minus sine theta equals 2 plus 2 times tan squared theta. This is to begin by working on the left side. We're going to get a common denominator. The common denominator is 1 plus sine theta times 1 minus sine theta. So the first one is going to be 1 times 1 minus sine theta. The second one it already had 1 minus sine theta, so we had to multiply the top by 1 plus sine theta. So I'm going to combine these. The denominator is 1 plus sine theta times 1 minus sine theta. The numerator is 1 plus sine theta plus, I'm sorry, that was minus. That one was minus 1 plus sine theta. This is sine theta that's negative. This is sine theta that's positive. So I'm left with a 2 in the numerator. 2 over 1 plus sine theta times 1 minus sine theta. It's a negative sign. I don't want that to be misunderstood. So I can multiply the denominators here. I can use FOIL, and I'll get 2 over 1 minus sine squared theta. So I've worked on the left-hand side, and I've gotten it down to that. Now I'm going to work on the right-hand side. So I want you to take this, and we're going to write it as okay, I'm going to come right down here. I'm going to write that as 2 plus 2 times sine squared theta over cosine squared theta. Well, I want to write this as with a common denominator. So the common denominator is going to be cosine squared theta. So the first one's going to be 2 cosine squared theta plus 2 sine squared over cosine squared theta. So I can write that all as 1, 2 cosine squared theta plus 2 sine squared theta over cosine squared theta. Factoring out a 2, I'm going to be left with cosine squared theta plus sine squared theta over cosine squared theta. We know that this is 1, so this becomes 2 over cosine squared theta. Well, we know that cosine squared theta is the same as 1 minus sine squared theta. So now I have the left side and the right side equal. I could have also said that we know that 1 minus sine squared theta is cosine squared theta and showed that they were equivalent that way as well. I hope that you do well on lesson 3.1.